morning students. Today we discuss about power. So what is power? Power means it is defined as the rate of doing work is called as power. The rate of doing work is called power. So here power means power is equal to, it is a ratio of total work to total time. So this means this power is called as average power. This is average power. Next one is instantaneous power. Next one is instantaneous power. What is instantaneous power? It is defined as the dot product of force and velocity of the body is called as instantaneous power. So therefore P instant is equal to F bar dot V bar. So that is Fv cos theta. So in the case of instantaneous power, the providing force does not change with time. So that means here force is constant, force is applied on the body. Then instantaneous power equal to the dot product of force and velocity of the body is called as instantaneous power. Now I can explain what is the relation between average power and instantaneous power. Relation between average power and instantaneous power. For example, if we consider a particle starts from rest, it is moving with some acceleration A, uniform acceleration A, then it travels certain distance, it covers time taken, that is as t. So then the velocity of the at time t is capital V. So then here average power is equal to work done by time. So in the case when the particle is moving some velocity, so that means its work done is equal to kinetic energy. So that means of m v square by t. So in the situation of m into v by t into v. So we know that velocity by time is called as acceleration. So therefore average power is equal to of m into, here v by t means acceleration. V by t is equal to acceleration. So therefore this value substitute in the equation ma into v. Okay, P average equal to of, according to Newton's second law, F equal to ma. So therefore F equal to ma. So in this case ma is treated as F into v. Here v is the velocity. So therefore Fv by 2. So you know that instantaneous power is the dot product of force and velocity. So therefore P average is equal to F into V means instantaneous power by 2. So this is the relation between average power and instantaneous power. Okay, next. Next one is some applications are there. So these applications are how to explain, calculate the power in different cases. Explain how to calculate power in different cases. So I can explain some applications. So application number 1. Application number 1. So in the application number 1, here a machine gun fires some n bullets per second released from the gun with velocity v. So here mass of the each bullet is m. Then the power of the machine gun is. So in this situation, here a machine gun fires some bullets, some number of bullets per second. Here mass of the each bullet is m, velocity of the each bullet is v. So in this situation, here small n is the number of bullets released from the gun per second. So here small n is the number of bullets released from the gun per second. Here t is the 1 second. So here power of the machine gun is equal to, here power equal to work done by time, we know that. So in this situation, when a bullet is released from the gun, some velocity, its energy is kinetic energy. So therefore, here kinetic energy is of mv square by time t. So here number of bullets released from the gun per second, that is the n by t. So therefore, power of the machine gun P equal to of m into, here n by t is a small n into v square. This is the power of the machine gun. Okay, next application 2. Next one is application number 2. In the application number 2, in this case, a conveyor belt is moves horizontally with constant speed. This is the conveyor belt. This is the conveyor belt. It moves horizontally with constant speed v. Then a gravel, some amount of gravel is dropped onto the conveyor belt at the rate of dm by dt. Then the belt is delivered some velocity v. So then the power of the conveyor belt is, so here power of the conveyor belt P equal to work done by time. So F into, here work done equal to F into S by T. So power equal to F into V. F into V. Here, according to Newton's second law, F equal to dm by dt into V. dm by dt into V. So here, F equal to, according to Newton's second law, here V is constant, M is variable. So therefore, F is treated as dm by dt into V. So here V is speed is constant, so dm by dt is variable. So therefore dm by dt into V into this way. So therefore power of the conveyor belt P equal to dm by dt into V square. So this is the power of the conveyor belt. Okay. Next, application number 3. In third application, a pump. This is the pump. Here, a pump lifts water from certain depth h. It delivers some amount of water with velocity v ejected from the pump. So then the power of the pump is, so here its depth d equal to h. So here water is delivered with constant velocity. So then the power of the pump is, here power equal to work done by time. So in this case work done is equal to sum of the kinetic energy and potential energy. So therefore work done equal to sum of the potential energy and kinetic energy. So potential energy is mgh, kinetic energy is half mv square by t. So in this situation, the amount of water is delivered from the mouth of the pump is dm by dt. So therefore P equal to dm by dt into here gh plus v square by 2. So this is the power of the pump. Right. Next application number 4. So here application number 4. In the case of application number 4, a car of mass n is moving on a rough horizontal road with constant speed v. Then the power of the car engine is delivers. So here power equal to force into velocity. So in this situation, this is the rough road. So then the applied force of the engine is equal to the, that means balance to the kinetic friction. So therefore F is equal to F square. Because in this case there is no acceleration, because when the car is moving with constant speed. So therefore P equal to Fk into V. We know that Fk equal to mu k into n. Here n is balanced to the weight of the car. So here n is normal reaction is balanced to the weight of the car. So therefore Fk equal to mu k into mg. So this value substituted in the equation. So Fk means mu k into mg into v. So this is the power of the engine. This is the power of the engine. Okay, thank you.